Hey students, this is Mrs. Bronk. Welcome to lesson 7-1, interior and exterior angles of triangles. So in this next module, we are going to be really focusing on triangles. And we're going to learn all kinds of different properties of triangles. And the most basic property of triangles, and something we've probably referred to in this class before, and I know you've seen elsewhere, is the fact that the angles in a triangle, which there are three of, right? 3 sides, 3 angles, there's always a set sum that they add up to. And you may remember that it's 180 degrees. So any 3 angles, doesn't matter what kind of triangle you could have an acute triangle, an obtuse triangle, a right triangle, you could have, and we'll talk more about those things, and we'll talk about what are called isosceles triangles, equilateral triangles, scalene triangles, any kind of triangle. It doesn't matter what kind of triangle it is. That's the one thing they all have in common, is that all 3 angles in a triangle always add up to 180 degrees. So it's always nice when we can really see with our own eyes why something might be true. And you'll see lots and lots of demonstration videos online if you go onto YouTube or just Google the triangle sum theorem proof. But here, just for what I am able to do in this video, I could show you a proof of that. So here's a triangle, and this triangle I've trimmed off the angles for. So these angles right here were trimmed off the corners, and this is just some arbitrary triangle. This specific one is an obtuse triangle. And so we have all these triangles that have been just trimmed off the edges, just off the corners. So we cut off all the corners. And then notice they're lined up here. So this one is over here, right? This one right here has been moved over there. And this one over here has been flipped and moved over here. And you'll notice that when they come together at their point, right, they make a straight line down here. And we can see here why that measure is 180 degrees, because it makes that straight angle, right? So that's just a visual proof of that triangle sum theorem. Now, mainly what we're going to be looking at regarding that is using that fact to find some angles in some triangles that we have unknown angles in, okay? So we're going to jump right in and try some examples. Start with some basic ones. So, for instance, in example A, I see that I have 2 angles already that are given in this triangle. One of them is 130 degrees, one of them is 20 degrees, and then one of them is labeled as 6x. Now, there's 2 ways I could approach this. I could use this triangle sum theorem just, directly, and just say if I take these 3 angles, the 6x and the 130 and the 20, and add them together, they're going to equal 180 degrees. Okay, and then I could solve that equation that results. Now, another thing I could have done is, since I already know 2 angles, I know 130 and 20, I could take those already off of the 180 sum. If I subtract the 130 and I subtract the 20, what's left over is I have 30 degrees. So basically, we know that this angle right here must be 30 degrees. And if we wanted to find x, then we could say that 6x is equal to 30 degrees. Okay, and then now we can see that x must be 30 divided by 6, which is 5. Now, we would have gotten there eventually anyway with using the full triangle sum, because we would have simplified by adding our like terms together. And then we would have subtracted the 150, leaving us with that 30 degrees left over in that triangle for that third angle to be. Okay, so x is 5, right? And, of course, that angle would be 30 degrees. Now, B is very similar to that one. So we're going to skip down here to C. We'll cross off B and go to C. Now, this time in C, there's 2 unknown angles. They both have an algebraic expression to describe them. I do know one angle is 70 degrees. So if I want to do that little shortcut, I could say, well, these 2 angles over here have to add up to what's left of 180 degrees when I take the 70-degree angle off, which is 110. So I know that these 2 angles together must equal 110 degrees. Oops, 110 degrees. So I could just say that x plus 62 plus x plus 72 is equal to 110 degrees. Oh, I keep doing that, sorry. 110 degrees and then solve from there. Or I could have just said all three of these angles add up to 180 right from the start, okay? So now my algebra just kicks in here. I'm going to put my like terms together. So I have two x's. And then when I add the constant terms of 62 and the 72 together, I get 134. And they together have to be that 110. I'm going to subtract 134. Now this might start to look like it's a little bit scary because you're like, well, wait a minute, it looks like I'm going to get a negative answer for this, because when I take 134, subtract it from 110, I end up with negative 24. And then if I were to divide by 2, I get negative 12. Now you're thinking, well, angles can't be negative. Well, the angles aren't going to be negative. If I take negative 12 and I substitute back in, that's going to make this angle negative 12 plus 62, which is 50 degrees. And it's going to make this one negative 12 plus 72, which is, 60 degrees. And now that makes sense because 60 and 50 and 70 add up to 180 degrees. Okay. So now if you ended up getting something that made angles be negative, then you have a right to be concerned about that. But here, x can be negative. It's just that when you find those angles using that value of x, they can't be negative measures. Okay. All right. So far, so good. All right. So let's maybe skip D. And let's look at E. So sometimes E trips up students a little bit because they see, I only see two angles labeled, and they didn't give me a measure of an angle. But they actually did. They gave you this angle as 90 degrees, okay? So again, if I use that shortcut here, if that angle is 90 degrees, then these two angles together would have to equal the rest of 180 degrees, which is 90 degrees. So I know these two angles together have to add up to 90 degrees. And I can just go from there to find x. So putting my like terms together gives me 12x minus 6 equals 90. I'm going to add 6 to both sides to solve for x. So that's going to leave me with 12x equals 96. And dividing by 12, let's see, 96 divided by 12 is going to give me x is equal to 8. So again, now, even though they didn't ask in this case, I could go back and find these angle measures by plugging in what I got for x. Sometimes they will ask you for those, so it's good practice to get into. So if I plugged in 8 there for x, that's 4 times 8 is 32 minus 2. That makes this 30 degrees. And it makes this one 8 times 8 minus 4. So 8 times 8 is 64, minus 4 is 60 degrees. And now I can see those three angles add up to that 180 degrees. So far, so good. Okay. I guess F is very similar to that. So we'll go ahead and skip F. And let's go to the next question, G. So as usual, we kind of follow this progression. We get more and more difficult. So when I look at G, okay, this drawing looks a little different. First of all, the triangle's sides are kind of expanded out, you know. So I do have the triangle here, right there. But then those sides have been extended out, right? So a couple things to think about. Number one, I see right here an angle that's a straight angle, right? So because that's a straight angle, I know that that's 180 degrees. And because the angle that's, right next to it is 130 degrees, that makes this 50 degrees. And that way I get that 180 degrees for this straight angle right there, right? That straight angle is 180 degrees. Well, now what? Because I still don't know really anything about this angle down here. Well, technically I do. Because even though it's not labeled, I actually know that this angle right here could be expressed as 8x plus 4. Now, how do I know that? Well, because these angles right here are vertical angles. And we just got done talking about vertical angles in our prior module. And we said that vertical angles are always equal. So this leaves me with three angles in this triangle, 3x minus 6, 8x plus 4, and 50 that are going to make that 180 degrees. So that's the equation I'm going to write. 3x minus 6 plus 8x plus 4 plus 50 equals 180 degrees. Or alternatively, I could have just taken the 50 away from 180 and said that these two, that these two things must add up to the rest of, oops, hold on, sorry about that. I just erased these two things. I could take that 50 off the 180, and that means these have to add up to 130 degrees together, okay? So either write the more elaborate equation, 3x minus 6 plus 8x plus 4 plus 50 equals 180, or simply subtract that 50 off and just write a little simpler equation. So now I'm going to put my like terms together. So I have a 3x and an 8x that adds up to 11x. My negative 6 and 4, those constant terms, add up to negative 2. Okay, now I undo subtracting 2 by adding 2. And the result is 11x equals 132. So if I just divided by 11, 132 divided by 11 gives me a value for x of 12. And again, they don't ask for this, but you could take that 12, plug it back in, and find these angle measures. For instance, this angle right here would be 3 times 12 minus 6, which is 36 minus 6, or 30 degrees, and so on. Okay? All right. So that's a pretty good start for the triangle sum theorem. And to wrap up this lesson, we're going to take a look at a related theorem. It still has to do with triangles. It still has to do with angles. But this time, it's going to be referring to angles that are outside the triangle and how they might relate to angles inside the triangle. And so for the rest of this lesson, we're going to be looking at what's called the exterior angle theorem. So first of all, an exterior angle of a triangle is formed when, I'm going to get a highlighter here, just a second. I need to get, we'll use green. When a side of a triangle is extended out outside the triangle, okay? So notice here, I just took that bottom side, I extended out, and that created this angle out here. And again, it's called an exterior angle, okay? Well, first of all, what I notice when I draw that exterior angle, I see that it's sitting right next to this angle inside the triangle. And I can see that those two angles make a straight angle. So they make 180 degrees together, okay? So this unique thing happens because of the fact that an exterior angle and the angle inside the triangle next to it add up to 180 degrees because they are a linear pair, or they're a straight angle. That there's a unique relationship between that exterior angle and the other two angles in the triangle. And what this exterior angle theorem says is this. Let me just clear my picture so I can go back to my drawing. It says this: the measure of an exterior angle of a triangle is equal to the sum of the measures of its two remote interior angles. So what they mean by remote, that means away from, like, when you have to use a remote control, you're not right next to something, right? You're using it so you can control it from away from where you're at. So remote interior angles mean the angles at the other two vertices. And what they're saying is if you take these two angles, these two remote interior angles, and add them up, you'll always get the same measure as this exterior angle. And the reason why that is because triangles angles add up to 180 degrees, and so do linear pairs. Remember, that was a linear pair there? So there's that relationship. Though what they share in common is that linear pair, and the interior angles of a triangle is that interior angle right here, right? So that's how that theorem works, is that the two remote interior angles add up to the exterior angle. So, for instance, here's a real simple example with just numbers in example A. So when I look at this triangle, I can see they extended out a side of the triangle, and they've got this exterior angle right here, and they want you to find the measure of it. Okay, so the measure of that angle, there's a couple ways I could actually find it. I could find it without even knowing this theorem. Okay, I could go back to my triangle sum theorem for this particular one and say, well, you know, I know these two angles in the triangle, so I could figure out what this angle is just by subtracting the two angles I know from 180, right? But that's not always going to work when we have exterior angles, because sometimes we won't actually know what those two measures are. Like maybe those will be the ones that have the variables, right? So instead, we have to actually apply this theorem that says if I take these two remote interior angles, which in this case are 66 and 74, and add them up, they have to equal this angle on the outside, right? Which and then in this case is called angle GHD. So I know that angle must be 66 plus 74, which is 140 degrees. So we know angle GHD is 140 degrees. Okay. So what about in example B? So again, this time I still don't see any variables, so that's good. But if I were to say put an X where this question mark is, so it's an unknown, I'd rather use an X than a question mark, then what this theorem says is that if I take these two remote interior angles, okay, so they're the two angles at the other vertices from where this exterior angle lies, right? Oops, I just colored it over so I can't see what it is. I know that they have to add up to that exterior angle. So I know one of the angles is 50. I know one of them is just called X, or the question mark. And they have to add up together to 82 degrees. Okay, so simple finding that value of X is just subtracting 50. So that leaves me with the fact that that angle that I've labeled as X must be 32 degrees. So that's 32 degrees right there. Okay. So far so good, right? Of course, now they're going to start to get a little more complicated. So again, here I could use a different strategy than using that exterior angle theorem. I could figure out what this measure is right here. Like, because I know one angle is 89. Oops, 89, and I know one angle is 33. That accounts for 122 degrees of the 180 inside the triangle. So I could find out that this angle right here, that I just put my little arrow on, is 58 degrees, and if that's 58 degrees, then these two angles right here have to add up to 180 degrees, because see how they make that straight angle right there, right? They make that straight angle. So that's one way to do it, and that's pretty easy too. But again, sometimes that's not going to work because you won't specifically know two angles in the triangle. So instead, what you can do is you can say, I'm going to add these two up, 89 and 33, the two remote interior angles, and they will have to equal, when I add them up, this exterior angle, which is described as 10x plus 2. And now I've got a nice simple equation to solve. That 89 plus 33, if I simplify that side, gives me the 122. And then solving the equation by subtracting 2 from both sides gives me 120 equals 10x, and then divide by 10 gives me a value of x of 12 again. So now let's say I wanted to find the measure of that angle, right? So if I wanted to find, let's say they also said find the measure of angle JRS, I could simply just fill that that value of 12 in for x and add 2, which gives me that 122 degrees. So again, they didn't ask for that in this case, but you certainly could find it if you needed to. Okay, so here seems like a good place for a you try question. So what I want you to do here is I'm going to pause the video, and I want you to give this one a try on your own. And then when you feel like you're ready to check your answer and your value for x, I want you to, we'll push play, and you can check to see how you did. So pause the video now. All right, so thanks for giving that one a try. I hope you were successful and found that the value of x must be 7. And again, you could plug back in and find the measure of that angle by substituting the 7 in. But your equation really just, again, goes back to that exterior angle theorem where you have to take the two remote interior, or in other words, the two inside angles at the other vertices, add them up, and they have to equal that exterior angle, which in this case was 102 degrees. Okay, so now they're going to start to get a little trickier just as we get more and more, variables and things like that. So I'm going to try one more with you, and then I'm going to have you guys try this final one for a you try question. So looking at example E, again, I've got an exterior angle. Now, how do I know, again, that it's an exterior angle? Well, because this side of the triangle is extended out and this angle's outside, right? It's formed outside the triangle by extending out a side, which is by definition an exterior angle. And I know by that exterior angle theorem that if I take the two remote interior angles, which are in this case R and Q, and add them together, right, they're going to equal that exterior angle. So that's what my equation is going to say. It's going to say 18x minus 3 plus 9x plus 7, which is what those two angles are, will equal 112 degrees. I'm going to put my like terms together, which means I'm going to put the 18 and the 9x together, making 27x. And my constant terms together, negative 3 plus 7 is positive 4. And now I'm just going to start moving so that I get the variable by itself. Move the constant term over. Move that 4 over by subtracting. 112 minus 4 is 108. So that leaves me with 27, x equals 108. And then divide by 27 to find out what x is. And I find out that x must be 4. Now, this time, these questions ask me to find these angle measures. So, like I said, sometimes they'll ask you to do that. Here they do. So, angle R is this one right here, right? 18 times what we just found x to be, which is 4, minus 3. So, 18 times 4 is 72, and subtract 3 gives us 69 degrees. And then to find angle Q, we're going to do the same thing, but we're going to use the 9x plus 7. So 9 times what we found for x, which was 4, plus 7, sorry. So 9 times 4 is 36, plus 7 is 43 degrees. Okay, so we did what they asked us to do. We found the value of x, and we were able to substitute back in and find those other angles. And now I actually could have found this even easier than that. I could have, if I wanted to find this angle right there, well, I know it's the rest of 180 degrees if I subtract that 112, because again, remember those make us a straight angle or a linear pair. So, but that's why they didn't ask for that angle. All right, so we come to our very last example in the lesson, and this is going to wrap up our lesson. Okay, and I want you to do this one as you try. So again, carefully write an equation to solve. This time it's going to be a little trickier because you're going to have variables on both sides, just a little tip. And you're going to find the value of x and then plug back in and find your angle measures. So again, this is our exterior angle right here. That's the exterior angle. So pause the video now. And when you've completed the question, tune back in and you can check to see how you did. Pause now. All right, thanks for giving that one a try. I hope you were successful in finding the value of x to be 8. Here's my equation that I wrote using my diagram. Okay, the two remote interior angles added up to that exterior angle, which was labeled as 14x plus 10. And there's my algebra that went into finding the value of x. And then plugging x value of 8 back in to find the measures of those angles. Okay, so that's it for our lesson today, and thanks for coming to class.